For this example, we want to find the area of the largest rectangle by area that can be drawn in the graph of y equals 25 minus x squared. We'll start by drawing a picture. There's our parabola, and the rectangle should fit between the graph of this and the x-axis so that the bottom side of the rectangle is along the x-axis, so something like this. Now what can we label in this picture? Well, I can label this length here as x and this height here as y, as this is a point here, x, y, that I will use as a reference. Now from this picture, what do I know? Well, I know that the area of this rectangle is going to be 2xy, because this length here on this side will also be x, the graph is symmetric across the y-axis. And then we know that y is equal to 25 minus x squared, so I can plug that in to get my area only in terms of x. And if I do that, I will get that the area should be 2x times 25 minus x squared, or expanding this out, 50x minus 2x cubed. And what is the interval here? Well, x has to be positive because there's a length in the positive direction, so it must be at least 0. And the biggest it could be is 5, because this point right here is at 5, 0, and that's where the rectangle stops being a thing. So 0 to 5 are my bounds here. Now I can look for critical points. Let's take the derivative of this function. A prime is 50 minus 6x squared. I want this to be 0 because it always exists. This will give me that 6x squared is 50. X squared is 50 over 6, which is 25 over 3. So my critical point is that x is 5 over square root of 3, taking the square root of both sides. I only want the positive square root because I know that my x values must be positive. So I can see the positive value there. That gives me my critical point. I can then check that and the endpoints to see where the maximum value occurs. So I have my endpoints at 0 and 5, and my critical point at 5 over root 3. If I plug in 0 to the area function, I get 0. If I plug in 5, I also get 0 because of 25 minus x squared. So that means this point will have to be the maximum, but we can still get its value. This will be 2 times 5 over root 3 times 25 minus 5 over root 3 squared. 5 over root 3 squared is 25 over 3. 25 minus that is 50 over 3. So this is 10 over root 3 times 50 over 3. And that will be the maximum value of the area for this problem. And that's how you work with that optimization problem to figure out the maximum area of a rectangle inscribed under this graph.